In data analysis, association does not imply causation, and causation can only be inferred from a randomized experiment. That is, if you want to show that some variable is causing another variable, you need to have an experiment that has random assignment to it between treatment groups and control groups. Making causal conclusions based on randomized experiments is often reasonable. However, making the same causal conclusions based on observational data can be treacherous and is not recommended. Thus, observational studies are generally only sufficient to show associations. All right, so what's the problem with causation here with observational studies? Well, suppose an observational study tracked sunscreen used in skin cancer, and it was found that the more sunscreen someone used, the more likely the person was to have skin cancer. So, does that really mean that sunscreen causes skin cancer? Well, in this case, there are some confounding variables. Previous research tells us that using sunscreen use reduces the skin cancer risk. So maybe there's another variable that can explain what's going on. Well, one piece of information that is absent is sun exposure. That is, if someone is out in the sun all day, they would they'd be more likely to use sunscreen and more likely to get skin cancer. So exposure to the sun is unaccounted for in this investigation. Sun exposure is what we call a confounding variable or lurking variable. This is a variable that is correlated with both explanatory and response variables, but was not accounted for in the study. A drawback of observational studies is that we can never know whether we have accounted for all possible confounding variables. You can search very hard for it, but just because you can't find one doesn't mean it's not there. For this reason, we can never make cause and effect conclusions from observational studies. Now, experiments, on the other hand, when you have random assignment, any confounding variable should be more or less equally assigned to both treatment and control groups. So if there is a difference, it's got to be because of the random assignment and not because of the confounding variable. All right, in the 2005 paper titled Kimchi and Soybean Paste Are Risk Factors of Gastric Cancer, researchers noted that gastric cancer rates were 10 times higher in Korea and Japan than in the United States. It should also be noted that Koreans and Japanese eat many times more kimchi than those living in the United States. Based on this information, can we conclude that kimchi causes gastric cancer? If yes, let's explain why. If no, state a potential confounding variable. Well, in this case, this is likely an observational study where they looked at past medical records, and went back to see who was eating I guess there's no reason to think this is an experiment. So, what are some other confounding variables that are possible? Well, it could be kimchi, it could be some other food, it could be genetic, could be geographic, environmental. So no, the study was likely observational, so other variables may be causing the results, such as environment factors or other foods.